what is up? My name is Mike and this is a Radical Academy, and in this video we'll be looking at how we can calculate the moles and the masses from the perspective of a reacting equation. Okay, so we can also do the same if you have been given a reaction. Okay, so most of you who are studying chemistry, you are aware that chemistry is normally based on a chemical reaction. Okay, so we have the simple thing on the board. So calculations from equation using the mole or using the mole concept. Okay, so what this means that we can have a chemical equation, a simple equation, a complex equation. So this is also how these people, the engineers or the chemical experts, okay, in industries such as maybe production of cement, production of alcohol, production of any kind of product, okay, that can be, that requires maybe the mixing of different quantities of substances. Okay, so now in this video also we can look at the combustion of carbon. Okay, so combustion also on that concept of view that combustion is where something is now reacting with oxygen. So combustion of carbon with combustion simply means burning in air. Okay, so burning in air, something reacting with oxygen. Okay, so combustion of oxygen, we can say combustion of carbon, so rather. So this we can have, say, the carbon. Okay, so the carbon plus the oxygen. Okay, now this is going to produce the carbon dioxide. Okay. Okay. So carbon plus oxygen equals to the carbon dioxide. Now this is a kind of the weight equation. Okay, so this is a weight equation, and then we can also have chemical part of the same chemical equation. So we can have now the carbon, which is solid, plus the oxygen, which is a gas. So make sure that whenever you're writing a chemical reaction or a chemical equation, always make sure that you also include the state symbol in which that particular element or substance is in. Okay, so carbon is something that is the hard thing, and then also oxygen is something that we cannot see. So that simply means oxygen is a gas, so we put a G, and then carbon is solid. So make sure even the way you're putting this should be underneath the element. Okay, so somewhere there. Okay, so it produces the carbon dioxide. So this is also the gas. And then now I want you to understand that when you're dealing with the mole concept, okay, now this time we are viewing the mole concept by using chemical equation. We want to know how much in terms of the mass or the carbon dioxide has been produced, or how many moles of carbon dioxide have been produced from reacting the carbon and also the oxygen. So from that concept or from that view, we can now, first of all, we need also to balance the chemical equation. So balance the equation. So whenever you are using the mole concept, calculation from the equation using the mole concept, always balance the equation. Okay, so in this case we have the oxygen 2, the oxygen there is 2, the carbon there is 2. Okay, so now we see that this is always balanced. Okay, now it is always balanced, or it is already balanced. Okay, so what you do is now is that we can now start describing how many in terms of what is the number in front of the carbon is 1, what is the number there is just 1, and then what is the number there, it is just 1. So now we see that from this point onward, you can say one atom one atom of carbon, okay, one atom of carbon react with one molecule, okay, one molecule of the gas oxygen, okay. So this is the gas that we need even in our breathing, that is respiration, to produce one molecule of CO2, which is a carbon dioxide, okay, the gas that is needed by many plants, or just in general most of the plants, okay. So we can now describe an equation, okay. We can describe an equation by using the numbers that are in front of these the elements, the atoms, and the compounds, okay. Meaning that these are what we call now, okay, the coefficients, okay. So these are coefficients, okay. We can use them to describe what is going on or what is happening in a chemical reaction. So if we are talking about the combustion of oxygen, we are saying one atom of carbon react with one molecule of oxygen, and then also one molecule of carbon dioxide, okay. So this means that also we can also convert them to masses, okay. You can say we can also convert them to masses, okay. So we can normally say that carbon is 12 grams, okay. You can also start now using the masses, the grams. And then the oxygen, remember the oxygen is just O2, so this means 2 times 16, and then I get 32 grams. Okay, so this is 32 grams, okay. Now, there also the carbon, I can also do like this, the carbon dioxide, can also do like this, 2 times 16, I get 32, and then 1 times 12, I get 12, okay. So this is going to be 4. So that will give me what? 44 grams, okay. So 44 grams of carbon. So what you are seeing here is that when we add now 12 plus 32, you get 44, because the equation is now balanced, okay. So we can now start now manipulating, calculating the number of moles, and just like that, and so on and so forth, okay. So that's how we can use the calculation from the equation using the mole concept. So what we can do now is that we can look at an example, okay. So we can look at an example. So now, when you look at the equation on the board, is that it is talking about the combustion of hydrogen, meaning we are making a fuel, okay. We're making a fuel by combustion, the process called combustion, meaning combustion is a process. First of all, write solution, okay, solution. This is going to be, now we have to write the equation, what is going on, okay. So this is combustion of hydrogen. So first of all, you write the weight equation, hydrogen plus also the oxygen. This can be also a reversible kind of or type of a chemical reaction to produce water, okay, to produce water. Okay, now once you do that, you convert this equation to the chemical equation. So this is going to be hydrogen, which is a gas, and then plus the oxygen, which is also a gas, and then forming now water, okay, forming water. This water can be liquid, okay, unless they say forms a steam. So make sure this water, if it was steam,